All right, welcome to part 2 of Unit 1 for Summer Geometry. So last time we talked about the concept of a point, line, and plane and how they're undefined terms of geometry, meaning they don't have any measure. So in this next part, the first new vocabulary term that we'll talk about is what's called a line segment. And that is a portion of a line. It has a finite length and it has two endpoints. So you can measure that. So as we talked about before, line AB would have line that contains point A and B, but it would be infinite length, and meaning it can go either direction. Whereas line segment AB is just a portion of that line, and instead of putting the arrows when you write line segment, there are no arrows above from B to A. So you can actually have a value for that. So finding the length of segment AB here using the ruler. So if you talk about millimeters, each spot is 10. So 10, 41, 42 millimeters here. Don't forget the unit of measure. For centimeters here, we have 4 centimeters and we're halfway to 5. So this would be 4.5 centimeters. So notice the key concept is a line segment you can measure. So the concept of being between 2 points means that point M is in between points P and Q if and only if they all three are collinear. And if you take PM and add it to MQ, that it equals PQ. So basically part plus part equals the whole. So two things in order for the point to be between two other points is it has to be on the same line, and when you add the two parts together, it has to equal the whole thing. So find LM. Well, notice M is between L and N, so on the diagram, so we know that LM equals, and we can take 4, which is the whole thing, and subtract 2.6, so that gives you 1.4 centimeters. So TU here, you would take 3 and subtract 1 3/8, so that equals 1 5/8 inches when you subtract. So if you're talking about this in terms of variables, so it says T is between S and U. So if we draw a line segment SU, T is somewhere between, we don't know where. But we do know that ST is 7x. We know that SU, the whole thing, is 45. And we know that TU is 5x minus 3. So to find x, we can go part plus part equals the whole thing. So therefore, 12x minus 3 equals 45. 12x equals 48 when you add 3 to both sides. So when you divide, x equals 4. So now it says to find the value of x, well, we did that. TU is 5 times 4 minus 3, which is 17. And then it wants ST, well, that's 7 times 4, which is 28. And notice 28 plus 17 is 45. So it all works out. So now it says, what is the value of x if and AB if B is between A and C? So go ahead and try this one on your own, and actually try the next two on your own, and then we'll go over the answers. All right, so if you look at number 5 first, So notice you draw it so that B is between A and C. So you have 3x plus 2, 7, and then 8x minus 1 is the total. So you add up 3x plus 2 plus 7 equals 8x minus 1. You solve and you get x equals 2. And then you get, when you put 2 back in for AB, you get 8. Same thing for number 6. M is between L and N. So you draw the picture. So x minus 1 plus 4 equals 3x minus 1. You solve to get 2, and then you put the 2 back in for Mn to get 2 minus 1, which is 1. All right. So the next concept that we're going to talk about is congruent segments. That means segments that have the same measure. So the symbol for congruence is the equal sign with a squiggly line on top. That means it's congruent to. And then you'll mark your picture with red slashes that indicate that these are the same. So here in the picture, we say that segment AB is congruent to segment CD. Objects are congruent, meaning if you have a segment, or we'll talk about angles, any object, they are congruent. When you talk about numbers, we say that they're equal. All right. So values are equal, objects are congruent. So if you look at the picture here in number 8, it says what segment is congruent to MN? Well, notice MN is congruent to MQ. So segment MQ is congruent to segment MN because they have the same measure. So we'll write a congruent statement. We say MQ is congruent to MN with the segments. So number 9, it says find the value of N, WY, and WX if W is between X and Y. So we'll draw the picture here. So here's X and Y, and here's W. So W is 6n minus, WX is 6n minus 9.5. XY, the whole thing, is 17. And WY is 3n minus 0.5. So then we find n, so we go 6n minus 9.5 plus 3n minus 0.5 equals 17. So we get 9n minus 10 equals 17. So we get 9n equals 27, divide by 9. So n equals 3. And then we have to find WY. So that's 3 times 3 minus 0.5. So that's equal to 8.5. And then when we find WX, do that over here. WX is equal to 6 times 3 minus 9.5. So 18 minus 9.5, which equals 8.5. And then the question says, is WX equal to WY? And the answer to that question is yes. WX equals WY, and that means the segments are congruent since the values are equal. All right, so go ahead. Let's look at number 10. So it says, given that these two segments are equal and AB equals 4x minus 2 and BC equals 3x plus 3, find x, AB, and BC. Well, since we know they're equal, that means we can set the equations equal to each other since they're congruent. So we can solve. So we subtract the 3x. So we get x, we add the 2. So we get x equals 5. And then, since AB is equal to BC, We'll just put the 5 into one of the equations. So 4 times 5 minus 2, that equals 18. So that means both of them are equal to 18. All right, that concludes our video for part 2. I will see you next time for part 3. Have a good rest of your evening.